Welcome everyone, this is Zon with Repro Products. Today's video is on how to create a dining table in Revit. I did a quick search on Google Images and found this table, and I thought it would be interesting to build this. This video is part of a series of videos that I'm creating on how to create Revit families. So let's go ahead and begin by creating this dining table. Here I am in Revit 2018.2. I want to create a new family, so I'll click New over here. Choose Furniture, since it is a type of furniture, and you'll see the furniture.rft. Click Open, and the file will be created. And when you work with this file, it'll give you two reference planes as a starting point. The two reference planes that you can see are called Center Left Right and Center Front and Back, and they both have Define Origins is checked, which means the insertion point of this table as it stands now is right here. If we want to have the insertion point to be maybe, say, the lower left corner of the table, then we can adjust that accordingly. As with all families, the first thing you want to do is take a look at the design of what you're working with and rationalize what you're about to build. For example, you have the top, you have the front, the back, the left, and the right. You need to create the skeleton framework that defines that tabletop. You also have four legs here that have a certain thickness and a certain depth and a certain height as well. So you need to create reference planes that define each one of those legs. Down here it looks like there is a horizontal wood slat going across from one leg to the other, and the same on the other side. And then this looks like a series of wood slats that are overlapping each other with a top. And so let's go ahead and start building the skeleton framework. I'll go here in Revit and I'll use the keyboard shortcut to create a reference plane. And I'll draw one on the left and I'll draw one on the right. When you're drawing the reference planes, try as much as you can to keep them aligned to each other and the start and end points to be the same so it looks cleaner for you. Don't forget to name your reference planes as well. So that's going to be the left side of the table. This will be the right side of the table. Create a reference plane for the back. And create one for the front. And again, make sure that the reference planes line up nicely. This one will be the back. And this will be the front. We also want to create the reference planes for the legs in plan. So we need one roughly over here and roughly over here. And over here. And over here. We also need reference planes for the part of the leg that does this over here, and the one down here as well. Oops. And from the picture, it looks like the legs also come out past the end of the table, the edges of the table, like so. So let's make sure we create a reference plane for those as well. Now, once that's done, we want to do some basic rules in place in this plan view. We'll create some dimensions that allow the table to grow equally on both ends. We'll define the length of the table and the width of the table, and the fact that it also grows equally from the center as well, since the center point, since the center of the table is the center point. And then I'm going to move this back over here a little bit. And we do know that we want to move these reference planes back a little bit. And for the legs, the extension that goes out past the edges is just a little bit. So I'll go ahead and place some dimensions for this side and this side. And let's set that to be an inch. And we'll hold that relationship, so we'll lock it. Same thing on this one. Now as for the depth of the table leg, we can either parameterize that or make that a stable size. So let's, for the sake of ease, let's make it a stable size. So I'll put this over on this side, a little easier to see. And this one as well. And let's set it to be something logical, say 8 inches for now. And over here is 8 inches. So let's lock that relationship as well. As for the thickness of the legs, they can be whatever thickness that we want. And again, if we want to parameterize it, we can parameterize it. Let's set that to 2 inches. Now, the location of the table legs from the outside edges also needs to be defined, because if you don't do that, as the table flexes, the legs are going to be not in the same position. Right now it's set to a foot. I think that's fine. I'll lock that at a foot. And I'll do the same thing on this one. Okay, so I'll lock that at a foot. And we said we wanted the legs to be 2 inches, so 2 inches. And since we want to lock that 2 inch, that way it'll hold. Same thing over here. This needs to be locked as 2 inches. So when we draw this shape of the legs, they're here and here and here and here, it'll hold that size. So now let's go ahead and parameterize the table length. And we'll do it as a type just for the sake of ease, and it's a family parameter, not a shared parameter. And the table width. Now let's head over to the front elevation, type in ZA for zoom all to fit, and take this level that they give us and pull it out of the way, because there is a reference plane at the bottom right there, and we'll call it bottom, and it's locked by default. We need to create a reference plane that defines a tabletop. We also need to create reference planes that define the thickness of the table, overall thickness of the table. And because there is some interesting void going on, I'll tackle that a little later. So let's get the overall shape down. Now, we'll place a dimension for the total height of the table and parameterize that. And then create a dimension for the overall thickness. And from the image, slide the image over. If this is 2, that's 2, that's 4, that's maybe 6 inches. So let's just kind of start from there. And so I'll take that dimension, and we'll call it table thickness. And we'll set it to 6 inches just for the sake of ease. And as for the table length, we'll do a standard 8-foot table is good. And for the width, let's do 4-foot table. And everything adjusts accordingly. Let's head back over to the plan view to make sure that it still looks okay. You may need to change the scale as well so that all the text and dimensions are a little smaller. It's easier to work with. And you may need to left click and pull the reference planes so that they actually cross each other very nicely to create the intersections that you need so that you can actually create geometry. So let's start by putting in some basic geometry. We know we have a tabletop. That tabletop goes from this intersection to this intersection as a rectangle. So I'll head over to the extrusion command, use the rectangle shape, and unfortunately there's no lock feature here, which is kind of what you see when you use a pick line method. They have a lock feature here. If they put that in the software, then when I use this rectangle command and I click lock, then all the lines that I'm drawing will be locked by default to the reference planes that I draw. Unfortunately, they don't have that feature if I'm using the rectangular shape command, so I have to manually lock them like this. So that edge of that magenta line is the edge of the table, and that agrees with that reference plane. Same here, here, and here. This is important because it's the relationship that you need to build in order for you to tell the software parametric dimensions control the location of these reference planes, which controls the plane of the geometry, which dictates the shape of the geometry. We'll head over to the front elevation and we'll finish the command and you'll see the extrusion. I'll put it in shaded mode so you can see it, and we want to push and pull the top of the table to the plane that we need. If you have to, you can also adjust your mouse sensitivity level if you have a good mouse, so it's easy to work with. And so there's our tabletop. It's real basic right now. It's just a rectangular slab, and it looks like that. So now let's take a look at the legs that we want to work with. We know the legs are right here. There's 4 of them. And if we take a look at the picture, we can see very carefully that the table legs, there is some space just around the edges of the legs so that they go through. So let's go ahead and make some minor adjustments, and we'll create reference planes again. And this time I'm going to use the pick method, and I'm going to set it to what's a good size? Say 1/8 of an inch. Okay, so we'll create a reference plane on the outside of an 1/8, outside of an 1/8, outside of an 1/8, and then come over here and do the same thing. And then down here, same thing. So now you can see where you need to create the geometry. So I'll head over to the Create tab again and do Extrusion again, Rectangle again, and I'll zoom in carefully. We want to pick this intersection here going to this intersection here. Whoops. So again, if you mess up, don't worry. You can use the Align command. And that way it cleans up nicely. And to be sure, you can use the Align command to align and lock those faces as well. And we'll do the same thing on all the other sides. You can use the mirror command if you want to in this situation to mirror that geometry. If you do so, you still have to align and lock. So if I select it, I can use the mirror command with the pick axis and pick this, and it'll do so. And then grab these two and do this again and pick this one. And they're created, but you still have to go through and you still have to align and lock. So let's align and lock. And a couple more. Now, for those who are used to working with Revit, you may see this. It's a little hard to see on my screen, but it is possible to notice this little hiccup that I have. When I'm zoomed in, and I use my arrowhead point to pick the reference plane. You notice my arrowhead point is not on that line. It's slightly off. This has to do with the graphics display driver. I have in a Dell XPS 9550 15-inch laptop. It has an NVIDIA Quadro gaming card at 960 GTX, at 960M GTX gaming card. And because of that, it's using a gaming driver. In addition to that, I have an integrated graphics card that is a Dell integrated graphics card built into the motherboard. The drivers sometimes conflict. And so if that were to happen, you just need to force the software in the NVIDIA control panel to use the dedicated graphics card driver, not the integrated one. So in any event, let's go ahead and head over to the front elevation, and we'll finish this command so it builds those legs. And you can see that they're built. See? Now, there are arrows, so again, we need to pull them up to where we need. I'm going to pull them through the table for now, and the bottom of the legs, I'm going to pull them so they go onto that horizontal plane and lock that. As for the top of the legs, if we look at the picture, it does go up above the tabletop surface, and there's this beveled edge. We'll handle this beveled edge a little later. So for now, let's pull this back up and get it to the height that we want. So if, let's say, we create a reference plane over here and dimension that reference plane, we can set it to 2 inches. That way we can select this extrusion and pull this down to that plane and lock it. Again, we want to name our reference planes so that way we don't get confused with things, and later we can use them easier when we're doing certain commands like sweep and blend. So I'm going to put this as leg top reference plane. This one is going to be table top RP. This is going to be table top bottom RP. We already named this one. It should be right. And then these are the leg ones, which I'm not really too concerned about naming for now. So now that we've created like this, let's look at this in 3D and see what we get. So our table looks like this. And if we look at our picture, there is a slight gap here and on all 4 legs. How do we do this in Revit? How do we get it to have that kind of a gap? Probably there's 2 ways to approach it. We can either go back to the plan view and model this tabletop extrusion so that it accounts for that spacing, or we create a void extrusion and place it at those legs so that the void extrusions cut the tabletop. I'm going to select this extrusion and edit the extrusion. And I'm going to use the planes that I already have. Since I created them earlier with a 1/8 inch gap, let's use that. And let's use the lock feature. Oops. So as you can see, the graphics card driver, because it's not seeing things properly, makes it very hard to snap to. So what I'm going to do is I'm going to pause the video really quick, and I'm going to switch the tabletop, the graphics driver. So give me 1 second. All right, so I'm back. Sorry about that. The NVIDIA graphics controller for adjusting the driver requires me to restart Revit. So for the sake of ease, I'm going to not worry about that and just going to continue building this one extrusion really quick, and we'll just go on from there. Okay, now let's do some cleaning up. That warning that you're getting that's blinking and making noise in the lower right corner basically is letting you know that you're creating the magenta lines on top of each other. So just be cognizant of that. So when you're cleaning the lines up, they clean up properly. If you mess up, it's okay. You know why? Because with Revit, when you do mess up like that, it will tell you. It'll actually will highlight in orange, as you are seeing right now, the line work that's overlapping. So it's okay. Just keep going. You could, if you need to use trim to corner and other commands that you have available to you to make it look nice and, draw it quicker and easier. But I'm trying to be methodical when I'm building the families. So, and then we have this over here. Again, I could, if you really want to, I can take this and I can mirror it across that axis. And then I can trim this back and unjoin that and then draw a line over here and clean this up. Now that we have the openings accounted for with an 1/8 inch gap, if I finish it, it'll tell me if I have any overlapping lines, and I do. See, if you take a look over here, here's my warning, and there's my overlap over here. So I'll click continue, and then I will clean this up. So let's clean that up. Delete, and try again. And there you go. So now let's look at this in 3D and see if we have the gap that we need, which we do. Okay. Now, because of that gap situation, when we start to flex this table for width and length and everything, that 1/2 inch gap needs to be locked down, or the 1/8 inch gap needs to be locked down, because if you don't, things are going to overlap and start to go crazy on you. So we place our dimension and lock those 1/8 inch dimensions. And then down here as well. So we should be okay if we flex it. Now, as always, when you do a lot of work like this and you get to a good stopping point, save your work. So I'm going to save this as a family. I'll put it under my temp folder, put it under dining table, and we'll just call it dining table. Now that we've done this, we need to flex the table to make sure that everything adjusts properly. So if I go over here into the family types window and I make some size adjustments, let's say it's 3 feet by 7, make the table height say 4 feet high, and the thickness say 1 foot. Does everything flex accordingly? And it looks like it does in plan view. How does it look in front elevation view? It does look like it's holding there. It does look like it's holding there. And I didn't get any warnings whatsoever. So it looks like we're okay there. So from the picture, let's go ahead and make some size adjustments. Let's make the table thickness not that thick. Let's do 8 inches at most. And we'll set this to a 4-foot table and say 10. There we go. So we have the basic one down. Now, what about from the picture? It looks like we have this slat over here and this slat over here that joins this table leg and the other one, and this one and this one. So we need that as well. So let's head over to either front elevation or left or right elevation. It doesn't really matter. We'll create reference planes that define the bottom of the slats that go across and the top of the slats that go across. And from the picture, the slats are kind of low. So I will place a dimension from here to here. And we'll make that slat base that slat at, say, 3 inches from off the ground. And we'll make the slat 8 inches. And we'll make it a uniform thickness. So we won't have to flex it. There's no need to. You can if you want to, but I'll just keep it like that. So if I head over to, say, the left elevation and shade it, we can see the area that we need to work with. And so that needs to go across to here, down to here, over here, and back up. So it's just an extrusion. So click Create Again, Rectangular. We'll zoom in here. And we will click here to here. And then let's verify that we align and lock the planes that we need. Now, when you are aligning and locking, make sure you align to the reference planes. Because if you're aligning to the geometry, you might get some weird hiccups and issues. So try to make sure you're aligning to the reference planes. That's a lot safer. And it's a lot more structurally sound. Like so. And if I head over to, say, the front elevation, and I finish this one, it's right there. We'll go ahead and pull it to where we need, which is right. I'm going to zoom in a little bit, because we have a couple of reference planes that are really close together. So let's go ahead and put it exactly where we need, which is there, and lock it, and this one as well, and lock it. Now if we look at this in 3D, we can see that one leg. Let's head over to the plan view, and we can right click and say select previous, and it'll get selected. And we can use the mirror command to mirror it to the other side. Then head over to the front elevation again, and we can see if we switch this to wireframe that it's over here. It's a little hard to see, but it is there. So what I'll do is I'll go to the right side elevation and do zoom all accents, and you can see that that's that geometry right there. We'll go ahead and align and lock, because we need to make sure that that geometry is locked, otherwise it won't work. It'll mess up on you. And so now that we've done what we wanted to do, we head over to 3D view and take a look, and it looks okay. Again, save your work and flex it to make sure it does what it needs to do. So in order for us to flex it so it works properly, and it really kind of tests the shape of this, go ahead and we'll set the width to, say, 3 feet. Something simple. And it adjusts. And the length as well, you could if you need to. So that it, see? There you go. So we can see that we didn't finish aligning and locking. So let's head back over to the left or the right plane, or the front or back, and make the adjustment. See? So we missed a couple of alignments. This is why we flex. Okay? So remember, align and lock to the correct reference planes and the right faces that need to move. And again, look in 3D. Should be okay there. And let's flex again. Let's make this 10 and make this, say, 3.5. And it looks okay. So let's set this to 4, because I kind of like it. The proportions on a 4x10. Now, since we have the base shape of it down, if we take a look at the picture, there's a lot of detail going on here. We can go through the same process to build the horizontal slat across here, and then this one, and then the opposite one, and then the ones here, and then build the top. That would typically be how you would want to build it. If I look very carefully, it looks like there's this dovetail here. So this may be a situation where this horizontal slat of wood and this one here has a profile that's not just a rectangle, but you might need to do a second horizontal extrusion that looks like a dovetail above it. So it looks like it goes into the wood. So let's go ahead and now build the reference planes that we need to define this slat and where it sits, as well as this horizontal one, this horizontal one, this one, and the one that I can't see in this picture. So to do that, let's head back over to the plan view. So when we take a look at the two main horizontal slats that go the length way of the dining table, it looks like from the picture that they are slightly in from the inside edges of the vertical legs. So let's create some reference planes that define where those slats need to sit. So I'll place one roughly here, and I'll place one roughly over here. Now, that distance that we want to place the slats from that plane is going to be off of that plane and this one. And we want to specify that distance. So from the picture, it looks like it's roughly 2 inches. So let's adjust this to be 2 inches. And then the slats themselves look like they're not that thick. It looks like maybe they are 1.5 inches thick. So let's set this excuse me, to 1.5 inches. And we will lock the 2-inch dimension so that it will always stay. And the table we need these horizontal slats to stay that thickness as well. So we just need to do the same thing. Also earlier I said make sure that you are drawing your reference planes so that they are nice and lined up. When you look at working with them and how they flex, you may need to adjust and pull them out further. So for example here, we may need to pull these out, and so it just helps in the sense of drawing them nicely and being able to control the start and end points of those points. And that way when you're dimensioning content, it's easier. So for example, dimensioning from here to here, and then from here to here as well. Also, when you place the dimensions, you notice that if I'm zoomed in, this dimension doesn't really align and lock itself to the other ones. And it's because it doesn't see them in the view that you're looking at. So if you zoom out a little bit so it can see the other dimensions, it will go ahead and place them exactly the way you want. So again, let's set that to 2 inches. And we'll set this one to 1.5 inches. And we'll lock these dimensions so that they stay that size and that position. In regards to the left and right edges, this edge and the other side, they look like they kind of, from this picture, line up either just below this table or along with this table. I'm going to assume that it's inside, so the face of this edge and the face of this edge is closer to the leg than it is to the face of this tabletop right here, to the right side of this table. So if that's the case, we want to create a reference plane over here somewhere that defines that stopping distance. So let's go ahead and dimension this as well from here to here. And we'll set it to some dimension that's logical. Let's set it to 4 inches. That's fine. And we'll lock this dimension as well. And we'll do the same thing on the other side. And it needs to be 4 inches. So again, set that to 4 inches. and then lock that dimension. So now we have that set up the way we want. Let's go ahead and draw the two horizontal slats. We can either draw them from top down or from left or right and extrude in the opposite directions. In this situation, it doesn't really matter which way we do it because when we flex it, it'll be okay. When we do the dovetail, however, we do want to do the profile from the left or the right side. So for the sake of ease, let's just go to the left side. And from the picture, it looks like this vertical and vertical horizontal slats are sitting such that they are actually going into the horizontal ones here by about 2 or 3 inches. So we need to put reference planes for those position heights here as well. So since I'm here, I can create a reference plane that defines the top of the slat and then going into the horizontal ones here. And we need to define that distance, and we can lock it at 3 inches is fine. And then the size of the slats themselves, they could be whatever we want. And from the picture, I'm going to set it to 8 inches. So you can see roughly this is where it's going to be, this one and this one. So let's go ahead and draw those extrusions. And again, rectangle. And here to here. And lock those faces. Same thing with this one. Now, when we drew the table earlier, the tabletop, and we drew the legs, we put in the 1/8 inch space gapping because it looked like it had it from the picture. But these look like they go nice and tight inside, so I'm not going to worry about that. Let's go ahead and finish this, head over to the front view, and look at what we have drawn. So we need to push and pull the face to the plane that we need, which is this one, and lock it. And the same thing with this side. And if we look at this in 3D, it should give us what we want. There we go. So now let's do the dovetails since we're along the same kind of relationship thinking. Let's head over to the front elevation. Or sorry, left elevation is better. And we want to draw that dovetail up here because we're going to put a horizontal slat above that. So let's draw a reference plane that defines the height of the dovetail, which is around here. We'll dimension that. And again, if you have to, you can set the scale to adjust it so things are a little smaller. And let's set this to, from the picture, say 1 inch. Okay. Maybe not 1 inch. Let's do 1/2 inch. Let's make it smaller dovetail. And we need to create a reference plane off the middle of there so that we can create a reference plane that is 0.25 inches on either side, like so. And the dovetail goes into, and let's set this to a 1/16 of an inch. And we'll zoom in a little bit and pull in here and here. Okay, so our dovetail is going to go from this intersection to this one, to this one, to this one, and back. Technically, the dovetail should go into the wood. So if I create a reference plane down here and dimension that as well, we can force that to be, okay, 1/4 inch is fine. And now we know that if I pull that reference plane down like this, and this one here as well, we can draw it. Okay? Let's head over to the Create tab, go to the Extrusion command. In this case, we'll draw the Line command. And we're going to draw from that corner to that intersection, to that end intersection, to that one, and that one. And then we use the align command to align and lock the faces that we know we can align and lock, like those two. And we'll finish it. Then we'll head over to the front elevation, and we can see that we have that. So let's again pull that out. And you know what? If we look at the picture, it looks like the dovetail is stopping short of the outside edge of the horizontal slats. So let's zoom in over here, and we will create a reference plane that is, say, 2 inches from the outside edge inward, like that. And we'll dimension this and lock this at 2 inches. Then we can take this and we can pull this over here to hit that plane and lock it. Same thing on the other side. Create a reference plane, use the pick method, the 2-inch offset over here. Create a dimension. Place it so it's lined up with the other one and lock it. And zoom in. Select our dovetail extrusion. And push and pull that edge so that it touches that plane and lock it. Oops, missed it. So again, just zoom in a little bit. And if we look at this in 3D, we should see it. And it looks like that. So we need to do the same thing on the other side. The fastest way, for the sake of the video, is switch this to wireframe. And I'm going to grab all of this right here, and I'm going to mirror it right here off of that. And then, because we've mirrored it, we need to align and lock that edge and align and lock this edge. Now we'll switch this to shaded. We'll do zoom all. We'll look at the 3D view, zoom all, and make it sure that it looks the way we want it to look. Good. Now we've done a lot of work again, so don't forget, save your work. Now once we have it saved, we need to flex it again, just to make sure everything's okay and we haven't messed up on any alignment and locking. So let's make this 8 feet and make it 3 feet. So we have, because we mirrored it, we didn't align and lock over here. So we need to head back to the left elevation and make sure that's aligned and locked as well. Because you can see that we have the shape right there and it's not placed over here. So we'll create a reference plane right here from the this one is aligned and locked. We'll set that one as well. Let's take this and do this, and then we'll move this so that it's placed there. Now, how do we make sure that it's aligned and locked properly? One of the things we can do is we can create a reference plane from the midpoint of that object up like this. Take that reference plane and pull it down a little bit so it goes through. And then we can align, we can dimension this to this to this and equal, and it will stay. Same thing here, dimension this to this to this, zoom out here, place it, and hit equal. Now let's try one more time. Let's change this from 3 feet to 4 feet and see if it adjusts. No, it still didn't adjust, which means we didn't align and lock something. Let's go ahead and take, for the sake of ease, let's do this. We will move this over again, place it there, and then see if we can align. We can align there and there, but we cannot align here and here. Let's align that edge, this, and lock it, and align to U and lock it. Okay. Now let's see if it stays. So this is the importance, obviously, of flexing the model to make sure everything fits properly and everything moves properly. So it seems like we're having hiccups with this one, so I'm going to just delete it. And I'm going to go over here and draw it manually again. So let's draw that plane, pull that one down a little bit. And we said earlier that this is 1/4 of an inch. Okay. So create a reference plane, pick method, 1/4 of an inch. One here, and the other one was, I think, eighth of an inch. So we look at this object here. Okay. Pick method. I think it was 1/16 of an inch. Come in at 1/16 of an inch. Yep, that's it. And then the base of it, we drew it at 1/4 of an inch. And then we will align and lock. That one's already aligned and locked. Good. Okay. So then we draw this again. Create extrusion. We do the pick method with a lock. Pick this one. Pick this one. Then use the line method and draw from here to here. And then from here to here. Again, trimming the corners. And then we'll finish it. And we'll head over to the front elevation. And you'll see that it is selected, so let's push and pull it. And lock it. And same thing over here. Push and pull this. And lock it. Now let's look at this in 3D to make sure it looks the way we want, which looks good. Save the work. And again, flex it. So we've got one that doesn't want to, let's go to the left elevation again, that doesn't want to align and lock and stay put. This one does. So what we'll do is we won't flex it so I can get back the dimension that I want. And I'm going to delete this. And then I'm going to put in that equality dimension again. From here to here to here. And lock it. Now let's see if it flexes. Ah, still doesn't. Okay, so then we'll force lock it. I'm going to delete that equality. And we will dimension this to this, lock it, and then this one to this one, and lock it. Oh, it'll over-constrain it. Okay, so let's see what's going on here. Okay, so what I ended up doing was deleting everything, recreating it, recreating the equality conditions, and then flexing. So now it looks like it's flexing properly. So now that we've built the dovetails, we need to draw the tabletop that is on top of this. If we take a look at the picture, we can see that it's just shy of this edge, of this horizontal one, and just shy of this and a little further on this edge and this edge. And it's going on the just shy of the edge of that dovetail. And same thing on the other side. So let's head back over to the plan view. And let's put in the reference planes that define that. Let's switch this to wireframe so we can see our dovetails. We want to create a reference plane that's over here, that's just shy of the dovetail, like that. And we'll dimension this from here to here. And we'll put this in at 1 inch. And we'll lock that dimension so we know it holds. Same thing with the other side. Create a reference plane over here. Dimension this as well. And lock that as well. So we know that that horizontal slat is going to go from here. And it's going to go, let's see, just outside this one. So we'll create another reference plane over here of 1 inch. Like that. And on this side over here, like that. And we will dimension this as well. And we'll lock this and this one as well. And lock it. So now we have the parameters for that table. Because we have the dovetail, we don't want to necessarily create a profile that's flat in elevation and have the thickness go down. We really want to go from the left or the right side, because we need to also define, so now we have the definition of the edge here. We know that that slab goes to here and it goes above the dovetail, so we need another reference plane that's say 1 inch thick above, like that. So I'm going to pull this one out here so I have an intersection to work with. And I'm going to dimension this one as well and lock that as 1 inch. And on this side, I need to pull this all the way out too. So I can see very carefully that we are going to draw a horizontal profile this way with the dovetail in mind. And it's going to extrude towards my face or away from the screen, towards the screen. Create an extrusion. We'll use the pick line method with a lock. We know we want the top. We know we have the left and the right. And the bottom is going to be this one. Oh, let's zoom in a little bit. It is this one. And because we have the dovetails, we need to pick the dovetails. And over here. And then we can use trim to corner to clean it up. Now over here, if I do trim to corner, I'm going to have the same kind of little hiccups that we did last time with lines overlapping and then have to redraw. You can use split element and use delete inner segment. And then just be very careful with what you're picking. So because my mouse sensitivity is off, I'm going to do it this way, and then I can trim cleanly like this. And same thing with the other one. So I'll say split with a gap, delete inner segment, pick the horizontals, trim the corner. So that's the profile shape. We'll finish it. It gets extruded. We'll go to the front elevation, and you can see it gets pulled like that. So again, where is the edge of this horizontal slat? It's going to go all the way over here to this plane that we drew earlier, and we're going to lock it. Oops, I missed. Again, zoom in if you have to. and lock. And we want it to zoom in over here. That edge. Lock it. Okay, let's look at this in 3D again. So there we go. That's our slat at the bottom. We can repeat, obviously, the horizontal members that go across here for these 4. So for the sake of speed, I'm just going to do the skeleton framework for where they sit, and then I'll do 1, and then I'll pause the video and time lapse forward so that it does all 4, and we'll continue from there, so you don't have to wait on me making all 4. So now we have the horizontal slats that I've drawn, 1, 2, 3, and the 4th one, which is over here. I've drawn them in with the reference planes and everything. And from the picture, it looks like the center ones go above the horizontal slat right here, that platform. And if we look at the picture, we can see that it goes above here and above here. It sticks out here as well. Looking at the model, it does look like what it's doing is fine. Now, if I switch this, however, to hidden line, you're going to see that this is a single slat right here. And these need to go through that slat. If I were to use join geometry to join this to this, I get this kind of situation. I don't want that. Okay, so I'm going to undo that. What we end up having to do is we need to take this particular extrusion and pull this edge over so it ends here, and then copy that slat to here and copy it to here and push and pull as well. So let's head over to a plan view and let's make that adjustment. So I'm going to take this, pull this across, and let it die right there. And I know it says I need to remove the previous constraint so that I can hold it to this one. And then I can take that slat that you see, now that if I do shaded, you can see that there's that piece. We go to the front elevation. We still have it selected. I can just mirror it to this side. And once I've done that, what I need to do is push and pull so that the edges are aligning and locking to what I want. So here's 1. Here's 2. Over here, 3. And this last one, 4. Now, this may get a little tricky because if we switch this to wireframe, we can see that we push and pull at hopefully those different edges. These are the areas that we saw in the front elevation that might cause some conflicts. So for now, let's hold this the way it is and leave that opening. Save the work and flex it to see if what we've done so far is good. So head over to here, switch this to say 3 feet and maybe 10 feet, and hit apply, and it adjusts, and it doesn't look like it's breaking. So let's set it to the shape that we originally like and want. And then we can head over to the front elevation. And we can take this one that we created here and we can copy it. And I'll just copy it horizontally this way. And then we can push and pull this edge in so that it's really, really narrow. And then we can move it back over to here. And the reason I do this is so that it's easy for me to push and pull the edges now and lock the edges that I need. There we go. So looking at this in 3D, it looks like we're good. We're finished. Now the only thing left to do is really to add some material to it. So to do that, we can select the legs, head over to the materials under properties, and just click inside here and add a new one. We'll call it vertical leg material. Then we can go to the family types window and make it whatever we want. So let's drill inside here. Let's use walnut. And hit OK. And we'll switch this to realistic. And then we basically rinse and repeat for everything else. So let's take these and the horizontal ones and this top and this top and this top and set them to a different material. So we'll go in here and we'll call this one, say, secondary supports. Secondary supports. And let's make that a lighter wood. Say this wood right here is fine. And then, oh, it looks like we're missing our dovetail on that side. Looks like it didn't get copied across. Okay, let's take this dovetail and then let's assign this the same material as the leg, vertical leg support. And let's head over to the left elevation or right elevation. And then we will mirror this object here. And once we've mirrored it, we can set this to wireframe so it's easier for us to align and lock those edges. Now we'll go back to the 3D view and we can see that we have the dovetail on that side as well. And let's see, so there's a couple things left that we want to do. The tabletop, now, if we take a look at the picture, the tabletop has two different materials. So I think from the construction standpoint, they built the slabs and pressed them together, so that it's two different woods with maybe something in between. In order to do this from a modeling standpoint, we can approach it two different ways. One way is we can take this slab that we created earlier and we would have to remodel it so that it has three different objects, one running this length, another one in the middle, and another one over here, so that it defines, each one can have its own material definition. Or we can do all of it as a single slab with one single material, maybe the lighter color one, and then we can paint the surface with a different material. It's kind of cheating, I know. So let's do this the right way. We'll shade this so we can see everything. We'll take a look at this slab that we drew for this tabletop. And we're going to edit the extrusion. So before we edit the extrusion though, this picture shows that it's divided equally in three. So let's take this and create reference planes here and here. And then we want to set up dimensioning so that it's dimensioning the reference plane to that plane to that plane to that reference plane. And we'll set this to be equal. There we go. Now we have our frame of reference to work with. So I'm going to select that slab. I'm going to edit this extrusion. And what I'll do is I will draw using the pick method, this one here, with the locking feature. And we'll trim this out. Now, we'll finish this. And, oops, there's a missing line somewhere. Let's see. Oh, there's some missing down here. Let's clean that up. Continue. And let's delete all these. And we'll finish this. So we effectively have one edge done. Well, then we'll just take this and we will mirror it off the center to get the second bottom piece. Now, we do need to edit this extrusion so that we can align and lock the correct edges. This is probably one of the tedious parts of working with families in Revit. So you'll just have to bear with me so that we can get it drawn properly. So I want to pick that plane. And same thing on this side. And then we'll finish it. Okay. And again, earlier I said those reference planes, try to draw them, and if you need to move them so that they make a lot more sense when you're clicking and dragging them. And then the last thing we need to do is the slat that's over here. So create an extrusion, rectangular one, and we'll put it here. And we'll lock all four sides. Head over to the front elevation, finish that extrusion, and push and pull that one to the desired location, which is going to be up here. Now if we look at this in 3D, we should see 3 individual slats. Okay? Then we can go ahead and make the materials that we want for these two. Okay? Click inside here and say new table top material 1. And then this one will be tabletop material 2. And so we can go to the family types window, make the tabletop 1 material the lighter one, which is wood, and then the tabletop 2 material, which is the darker one. And there you go. And so we have our table created from that picture. Oh, I missed one. Let's go ahead and pick that one and associate that to the secondary supports. Oh, this one too. So now our table looks complete. Again, as always, save and flex your work. Okay. So this has been a good tutorial on how to create this table in Revit as a dining table, and it'll flex properly from the image that you saw from the Google search. Thank you very much for watching, and look forward to another Revit family video series. Take care.